Okay, yeah, so now that we have that all figured out, my name is Field Watts. I recently completed my PhD at the University of Michigan doing chemistry education research. And I'm really excited to be here today to share sort of one of the final outcomes from my dissertation research. So I'm specifically going to talk about a feedback tool that I developed to provide automated and content-focused feedback, specifically on a writing assignment in the context of an organic chemistry course. So this is specifically focused in the context of what we call writing to learn assignments. So these are writing assignments that we can implement into STEM classrooms to really support students' conceptual learning and disciplinary thinking. So I often like to talk about writing to learn assignments in contrast to learning to write assignments. So if we're trying to support students with learning to write, you might be thinking about writing essays or writing lab reports, and the focus is really on actually like how to put together sentences and ideas in the writing process itself. But with writing to learn assignments, the idea is to really use the process of writing so that students can just practice engaging with conceptual ideas and in that way support their learning. So one of the classes that I'm going to be talking about today, and that was really the focus of my dissertation, where we implemented these writing to learn assignments, is in the context of an organic chemistry course. So a lot of my research and a lot of the research of the group that I worked with focused on different assignments in this context and how it can support their learning for organic chemistry specific topics. So things like acid-base chemistry or reaction mechanisms. But this is part of a much larger program at the University of Michigan called MWrite, which supports the implementation of effective writing to learn pedagogy in STEM courses across the university. So through the MWrite program, instructors can learn how to develop assignments and implement them into their often large enrollment STEM classrooms, and develop assignments that have clear expectations for what students should be including in their writing, include components for interactive writing, typically peer review, and then also include features in the implementation of assignments to promote metacognition, often through having students revise their writing. And this is a rather large program at the University of Michigan, which since it started in 2016 has supported over 18 faculty members across 65 courses, and by now well over 35,000 undergraduates with engaging in different writing to learn assignments. So as you can imagine, at a large research institution like the University of Michigan, especially in these large, often introductory, large STEM courses, one of the sort of significant challenges with these writing to learn assignments is the idea of providing students with feedback. So this graph here shows the enrollment in the chemistry course where we implemented these assignments. And we typically implemented these in the winter semester, which is shown in the purple bars up there. So if you can see, the typical enrollment is around 800 to 850 students per semester. And then one of the other key components with the writing to learn assignments is that we have students submit a first draft of their assignment, undergo peer review that's focused on providing content-focused feedback, and then students have the time and are required to submit a revised draft to their assignment. So each student is submitting 2 drafts. There's also a lot of peer review comments that are being submitted. And then typically there are anywhere between 3 to 5 writing to learn assignments per course. So you can just imagine the sheer number of drafts that students are submitting and how challenging that can be as an instructor to think about how am I going to give students feedback on their writing. So that really motivated this research objective for the project, which is to explore how we can develop a feedback tool to provide students with this type of automated formative feedback. So we turn to the literature on providing automated feedback in this context, and a lot of the existing research focuses specifically on providing feedback in the context of the quality of students' writing. So things like argumentation skills or how to engage in academic writing. So we were really focused in on the writing to learn aspect of this pedagogy and asking how we can support conceptual learning through this type of automated formative feedback. And then in the context of undergraduate STEM instruction, there are several studies looking at using machine learning models for open-ended type assignments like the writing to learn assignments And a lot of these machine learning studies focused on scoring student responses and validating using machine learning models for that scoring. So we were really interested with this project in how we can sort of extend that literature. We know we can develop models to look at things like student writing and to score them for content-focused things. And we were wondering how we could sort of build on that literature to use those models for formative feedback. So I've been talking a lot about formative feedback, which is really the goal of this specific feedback tool. So we're not interested in using this to give students grades or any type of summative feedback, but rather to really promote students as they're engaging in the writing process. So for this reason, we turned to a framework for delivering formative feedback to promote self-regulated learning. And this framework really suggests how whenever we give students some certain task, as educators, we have certain goals or criteria that we want students to meet with that assignment. And then whenever students work on a task, they undergo several internal and self-regulatory processes as they're working on that assignment, setting up internal learning goals, and eventually producing some response to that task, which we as instructors can observe as an outcome to that task. And then we can provide external feedback, and if students have the opportunity to go back and revisit their work, they can go through those processes again and maybe modify those internal learning outcomes, for example, and really think about what concepts they're including in their thinking for responding to these tasks. So this framework maps on nicely to the writing to learn process that we already use in these courses, where we give students the writing to learn assignment. They undergo these internal processes to produce a first draft to their response. And then currently, the external feedback that they receive is in the form of peer review. And we have a lot of work that shows the benefit of peer review for students, both for reading and receiving feedback. And for this project, we were really interested in how we could supplement that peer review and to provide this formative feedback through an automated tool to sort of supplement the peer review feedback. And so a key aspect of this theory is that to support self-regulation, we need to think about providing high-quality feedback. So this means that the feedback should clarify what good performance looks like, facilitate students' self-assessment of their work, and then also encourage dialogue. So now I'll go through what the tool looks like, and this is sort of organized based on this Technologies for Automated Feedback Classification framework, which I found really useful for thinking about the different pieces that went into consideration for developing this tool. So as I've mentioned, the setting for this is an undergraduate organic chemistry course, and specifically in the context of these writing to learn assignments. And then as for the feedback property, just to reiterate some of these points, the goals with the feedback tool was for it to be formative. So the idea was to develop a tool where students could use this automated feedback to get input on their assignment as they're working on their writing. So the writing to learn process typically spans about 2 weeks for each assignment. So the idea is to have a tool available that students could use throughout those 2 weeks to get feedback. And then we wanted this feedback to be suggestive in that it could provide really content-focused feedback in alignment with writing to learn pedagogy. And we were also interested in making sure that this feedback was adaptive so that it would modify based on an individual student's response. And then as for the architecture of the tool, we focused it specifically, since it's sort of in the early development stages, on one specific writing to learn assignment, where we asked students to, where we elicited explanations of an organic chemistry reaction mechanism. So I won't go into the details of the chemistry for you all, but the goal was just to get students to be explaining what's going on in this reaction shown here. And then based on my prior work looking at students' responses to this assignment and a lot of qualitative research that went into reading and analyzing students' writing, we ultimately evaluated students' responses to this assignment using a set of machine learning models that can identify features of students' writing aligned with this framework shown here. So the framework is essentially sort of organized into features of this type of mechanistic explanation that students should be sure to include in their writing. So things that the chemistry education indicates are typically challenging on as much, which are often reflective of more surface level thinking and aren't necessarily the goal for this type of task. And then there's other features that are just necessary for this type of writing. And essentially the way that these machine learning models work is it takes a student's response and splits it by sentence. And then for each sentence, it can predict whether or not these different features are present in their writing. So just briefly, I wanted to show sort of how these models perform. So these are all CNN classifiers, binary classifiers for each of these different features that we were looking for on a sentence level in students' writing. And in our prior work, we were able to develop these models with high % accuracy and Cohen's kappa values above like the 0.7 cutoff for assessment purposes. And then the way the tool actually works is that a student can go to the tool, they can submit their draft, their work in progress, and then it'll classify all of the sentences in their writing and compare then their sentences to the corpus of prior responses that we have for this assignment. And then based on that comparison, it'll give students guided feedback depending on where they sort of sit in comparison to the corpus of assignments for this course. So then this is what the tool actually looks like, so I'll just play the video real quick. So it was developed in Streamlit, which is an open source platform for developing tools using Python. And essentially those paragraphs there just sort of explain the goals of the assignment again for students and then how to use the tool. And then students can go in and copy and paste their writing and click submit. And then it'll take just a few seconds to run. And then students can scroll down and sort of see a graph of what the models saw in their writing. And it shows the different features and how many sentences it identified pertaining to each of those features. And then it also is color-coded based on the model the framework that I talked about earlier to help students know what maybe they should be focusing on in their writing. Let's see. Okay, and then on the sidebar there, students can expand and get definitions of all of these features in case they aren't quite sure what they represent, so that they can understand more specifically what these are looking for in their writing. And then students can scroll down finally and see tailored suggested feedback based on their response. So then using this tool, we did just a very small pilot study in an interview setting just to see how this tool might support self-regulated learning. So the students talked about how it would clarify good performance. So for example, this student said that the tool can show you where you can be more specific. It can tell you might want to focus more on this. And then they talked about how the graph indicates what they should definitely include and outlines the expectations for what they should have in their writing. These students also talked about how it could facilitate self-assessment. So talking about how it puts into their mind what they need to change, how they need to change how they talk about certain features, and then they might go through their draft again and highlight things that can be changed or places they need to add or clarify. And then lastly, the students did talk about how it could support peer guidance. So the students said that they would do edits based on peer review first, and then they would put their writing into the feedback tool and address things further. So we saw that, at least from this small pilot study, that students wouldn't necessarily replace the peer review, but would use this to supplement peer review. So the key finding from this is really that we can develop these types of tools for automated formative feedback, and just from this really small study, they do show promise for promoting self-regulated learning. So we also got some suggestions for future development. So for example, adding a tab that could display the assignment text and rubric criteria just to clarify those expectations further. And other just usability features like the ability to upload a document or PDF, as well as the ability to actually see which sentences were tagged with different features. So just to conclude, sort of the objective of this short research paper was to investigate how we can develop this type of feedback tool in the context of writing to learn to provide students with automated, formative, and content-focused feedback. So we've shown how we can translate machine learning models into this type of tool. And then from the pilot interviews with students, they do seem to show promise with how they would use this tool to promote self-regulated learning processes. So as for future research, I'm really interested in actually implementing this in the classroom and doing a larger scale study to see how it works in the classroom setting. And then also, as you can tell, this is very content focused at this stage and really specific to a specific set of assignments. So I'm really interested in developing approaches that could perhaps automate the analysis of content focused writing assignments to sort of streamline the feedback tool development. So with that, I would just like to end with acknowledging the Schultz Group, where I did my PhD work, and I had a really great supportive team to do all of this work there. And I'd specifically like to acknowledge Dr. Amber Dude for helping me with all of this project, and then my advisor, Ginger Schultz, and then also Professor Ann Geer, who together were the PIs for the MRI project.
Thank you very much.
Thank you.